Hello everyone. We recently added one more concept to our concept map of triangles. We got to know about the fact that if in a random triangle we join the midpoint of any two sides of a triangle, then the line segment obtained is parallel to the third side and is half of the third side. This fact about a triangle is of utmost importance, and so it's important to name it. It has been named as midpoint theorem of triangles. Now let's explore this idea to the quadrilateral. Here I have made a random quadrilateral, and here I've joined its four midpoints by this pink color. Okay, so what is your observation? Here you can see the quadrilateral formed by joining the midpoints of the sides of a quadrilateral is looking like a parallelogram. No? The quadrilateral outside is a random quadrilateral. You may try it at home. Just make a random quadrilateral, label the midpoints of its four sides and join them. Okay, you will get a parallelogram. Now the thing is, we need to prove it. How to prove it? It's quite simple. We can use midpoint theorem of triangles. Many properties of quadrilateral can be proved by dividing them into triangles. We have proved the properties of quadrilaterals by means of congruency, no? And congruency is meant for triangles, no? So here also we are going to use triangles to prove properties of quadrilateral. Okay, now we have to prove this is a parallelogram. So what we need to do? Nothing more. We just need to divide this quadrilateral into two triangles by joining any of its diagonal. One diagonal is enough. So I'm joining here this diagonal AC, and let's see how will we proceed. Here you can see I have divided this quadrilateral into two triangles, and now I'm going to look at it as a triangle only. I have just hidden the rest part. What can you see here? Here you can see a triangle in which its two midpoints are there. Okay, so by using the midpoint theorem, what can we say? We can say this EF is parallel to AC for this picture. No, EF is parallel to AC and it is half of it. Okay, now if I see this side here, we have one more triangle in which the midpoint of two sides are G and H. Therefore, GH is parallel to AC and GH is half of AC by using midpoint theorem. This is how we write it, as BE equals EA and BF equal FC. Therefore, EF is parallel to AC and EF is half of AC. Similarly, you can write for this triangle, and then you can label that as equation 2. And from equation 1 and equation 2, what will you get? That EF is parallel to AC and EF is half of AC. Similarly, HG is parallel to AC and HG is half of AC. What does this mean? Both of them are parallel to AC. Both of them are half of AC. That means both of them are parallel and equal. Okay, here comes our one more important theorem of parallelogram, that if one pair of opposite sides of a quadrilateral is equal and parallel, then we can say that the quadrilateral is a parallelogram. You can use that theorem in this, and you can prove in 2-3 steps that EFGH is a parallelogram. So we are able to prove it by using the fact of triangle, the new fact of triangle, which is midpoint theorem. So it was easy to prove. Now if we changes the outside random quadrilateral into some specific one, does the property of this inner parallelogram changes? See, it is going to be a parallelogram in any case, because for a random quadrilateral it was a parallelogram. So if we join the midpoints of any specific one, for sure it's gonna be a parallelogram. But is the inner side shape is much more than a parallelogram or not? That we need to explore. So I'm joining the midpoints of the sides of these quadrilaterals. Here I have joined the midpoints. Now let's analyze them. So here the outside figure is the parallelogram, and the figure obtained by joining the midpoints also looks like a parallelogram. But is it something more than a parallelogram? So here, see, square, though it doesn't look like, okay, not even rectangle, because this angle is quite obtuse. Now we have to see whether it is a rhombus or not. Okay, for rhombus, this side should be equals to this, and these can be easily proved equal if these two triangles are congruent. Now let's see, are these two triangles congruent? Okay, we know this is gonna be equals to this, because being a parallelogram, opposite sides are equal, and these two are the half of the equal side then. No, so let's see, this is x and this is also x. Now this is the one side of the triangle of the parallelogram, and that's the midpoint, so this is y and this is y, so these two sides are equal. Now we need one more equality. Is this angle equals to this angle in a parallelogram? No. So as this is not equals to this, that means these two triangles are not congruent. See, we are not getting the third equality, that's the secondary thing. But one more we got to know, that these could be, if these are to be congruent, then this must be equal to this. But we know this cannot be equal to this, okay, for a normal parallelogram. That means if we join the midpoints of a parallelogram, the figure obtained is not square, not rectangle, not even rhombus. It's only a parallelogram. So let's move to the next picture, which is here a rhombus. If you see carefully, for sure it's a parallelogram, but you can see the angles, all angles are looking 90 degrees. Okay, so it's possible that it's one of this, or rectangle or square. Okay, now let's see how to do it. So here, for sure it's a parallelogram. Okay, now let's see whether these two triangles are congruent or not. If these two are, why are we doing it? If we could prove these two congruent, we can say this is equals to this, which means this figure is going to be a rhombus. So again, this is going to be equals to this because this is a midpoint, so let's call them x. Now this is also gonna be equals to this because they are the equal halves of the equal sides. But do we call them y? No, only x, because in a rhombus this is equals to this. So if this is 2x, this is also gonna be 2x, and this is gonna be x. So these two triangles are gonna be congruent. But now, is this angle equals to this? No, it's not compulsory for a rhombus. For a normal rhombus, these two angles are not equal. That means the figure obtained does not have this side equals to this. So if this is not equals to this, for sure this triangle is not, this quadrilateral inside is not a rhombus, it's not a square. So what is it? There is a possibility that it is a rectangle, or it might possible it's not even a rectangle. Now let's see how to prove whether it is how to check whether it is a rectangle or not. So here, as the two sides are equal in a triangle, that means this angle equals to this. Let's call them AA. Similarly, these two are BB. Okay, let's call this as T, and let's call that as M. Now, the sum of these three and these three are gonna be 360. So 2A plus T, 2B plus M equals to 360. But T plus M being the adjacent angles of a parallelogram of a rhombus, these are going to be supplementary, means their sum is 180. So if their sum is 180, that means their sum is also 180. Okay, now 2A plus 2B 180, that means A plus B is 90. Now focus here, A plus B is 90. Therefore, being a linear pair, this angle for sure is going to be 90 degree. Similarly, in the same context, we can say all of these angles are 90, or you can simply say this is co-interior to this, so 90 and all four. That means this figure is a parallelogram with all angles 90 degree. That means it is a rectangle. There was one more way to prove this. If you don't want to go through this AT and all, we can join this. We can join the two diagonals. Okay, we know the diagonals of a rhombus meet at 90 degrees. So these four angles here are going to be 90 degree. Now, as it is a parallelogram, no, we know this is a parallelogram. So the opposite angles of a parallelogram are equal. That means this is going to be 90. Okay, and being co-interior, this is 90, that is 90. Anyways, we need this 90. And as this is 90, so this is 90. So we can prove it by using the diagonal property of the rhombus too. So now let me tell you, in this exercise, means 8.2, you can use diagonal related properties also of the quadrilaterals. Now here the outside figure is a rectangle. Okay, and we have joined its midpoint, so for sure it's a parallelogram. We can easily prove it by using midpoint theorem. Now we have to see it's because of the outside figure rectangle, is it taking any specific shape? Okay, is it something more than the rectangle? To prove that, we always start with this, because we have to find out whether it is a rhombus, means its all sides are equal or not. So anyways, if it is, we have to prove it. If it is not, we have to knock out the possibility that it is a rhombus. So let's see whether these two triangles are congruent or not. Being a rectangle, being a midpoint, this is x, and this is y, because they are the halves of the equal sides. Now these two triangles, are they congruent? Yes, because this is 90 degree, because the outside figure is a rectangle. That means these two triangles are congruent, and so this overlap over this, that means this is equals to this. So a parallelogram with the adjacent side equal is called a rhombus. Now we have to see whether it is a rectangle, because all sides are equal, so another possibility comes out to be that it can be a square. For that, we need to see whether this angle is 90 degree or not. We can clearly see the angle is not 90, they are acute. Or moreover, you can easily prove by joining the diagonals. You can see, we already know the diagonals of a rectangle do not meet at 90 degree. When this is not 90, it is something else. So this figure here is a parallelogram, okay, because this is parallel to this. Now, so this is parallel to this, that means this is parallel to this, and this is parallel to this, and again this is parallel to this, and this is parallel to this. That means this is a parallelogram, and in parallelogram opposite angles are equal. When this is not 90, this will not be 90. That means the quadrilateral formed by joining the midpoints of a rectangle is a rhombus, not a rectangle, and not a square. Here we have a square, and these two triangles are congruent here. That means the parallelogram which was inside is not just a parallelogram, it is also a rhombus, because being these congruent will give us these two as equal by CPCT. Also, if we join the diagonals of a square, we know that they meet at 90 degree. Now, as this figure is a parallelogram, so this angle is also 90 degree. Now, it's a rhombus with all angles 90 degree. That means the inside picture is also a square. So we got to know that the line segment, that this quadrilateral formed by joining the midpoints of a square is also a square. So we basically reach at these conclusions. Now you have to prove them neatly with less but sufficient words and steps. Thank you.